Hello, dear audience. I'm Seyed Mahdi Mousavi, and I'm working as an assistant professor in Doğuş University and Mechanical Engineering Department. Today, I'm going to give a short, presentation related to the water scarcity, which is shown in the figure. Water scarcity is one of the biggest, issues and let's say problems during last decades which human faced with it. And of course, we are looking for some solution. Today, I will talk and discuss about the solution which is known as desalination technology. Now, my presentation is divided into 6 main sections. Firstly, I will talk about water scarcity. I will talk about the need. Later, we will consider some sources of the fresh water, and of course, we need some discussion related to desalination. Desalination definition will be considered. As we know, desalination means removing dissolved water from the water. The thermal desalination process, which can be considered in 2 parts, or it can be categorized in many parts, but 2 sections of them as solar steel desalination and humidification. Dehumidification will be considered during this presentation. Before then considering the water scarcity, I think it is better to give some idea about the amount of water in our Earth. Almostly 97.5% of the Earth is covered with ocean water. But it should be mentioned that almost 75% of the Earth is covered with the water. But of course, all of this water is not available for us as drinkable or potable water. Now, as I mentioned, 97.5% of the water is ocean or sea water, which is not drinkable, and the remaining part, the 2.5% consists of 2 sections. Firstly, permanent snow or glaciers, and second is the ground or let's say surface water as river, lakes, and shallow wells But how much of this water is available for us? Of course, the snow or the glaciers are not available for us, and the available part is almost 0.5% of the total water. It means that there is scarcity of the water. Now let's consider the water stress for the world. This figure is giving some information about the countries which face with the water scarcity. The red color means they are under pressure. At the extremely high water stress. This map is prepared in 2015. If we look at the map, we will recognize that Turkey is not in the water stress. Since, as we can see, the color is not almostly red, and this is between the 40 and 80%. And then we can say that just the center of the Turkey is not, under extremely high pressure, is under pressure. But this is the map which is prepared in 2015. Let's consider the prediction. According to prediction, water stress in 2040 says us that many countries will face with water scarcity, and as unfortunately as can be seen from the picture, Turkey also will be in the water scarcity or water stress. It means that we will have one problem. Then we are looking for some solution for this problem. Some reasons can be given for the water scarcity, as population growth, as economic growth, as the as actually climate change. These actually reasons can be considered as the main reason of the water scarcity. Now we wanted to talk about finding more fresh water. There is actually almost three main sources of the water. Fresh water, let's say fresh water or potable water. One of them is the relocating water. Another is the conservation and reuse of the water. And the last one is developing new sources of the water. But for the relocating water, we can give this actually definition: transporting water from the water-rich area to the actually water-poor area. We have one actually famous example also around us. The example is transporting water from the Mersin of the Turkey to the Karnia in North Cyprus. This is one example of relocating, or let's say transporting water. How about the other? The conservation and reuse actually can be actually introduced by increasing, or let's say developing the culture of people. But we will consider the developing new sources, since we need some new sources. If you can ask me why we need some new sources, since during the last decades, especially after the Second World War, we have something same as increasing or growing in the public population, but simultaneously the demand of potable water increased twice. It means that according to previous pictures, we are in the water scarcity, and even we will be faced with this water scarcity. Now, it is better to talk about main source of the fresh water. Almost there is three main sources of the fresh water. Firstly, seawater. Second is deep wells, and the last one is wastewater. I wanted to give some analogy between this topic and thermodynamics. In thermodynamics, we know, according to the second thermodynamics law, if you wanted to convert work to the heat, you can do it easy. But the problem is coming when you wanted to convert heat to work. For converting heat to work, you need some more devices. And this device is known as heat engine, or let's say as a heat engine cycle. There is an analogy, as I mentioned. And here also, for transporting, or let's say for converting the seawater, which is not drinkable, to the potable water, we need some technology. This technology known as the desalination technology. Of course, deep wells need again technology. You have to go deep parts of the underground. It needs more technology, but in this central place, this is so difficult to take water by using this technology. For the wastewater, especially in industrial actually sections, we can consider this actually method. Of course, we can have some treatment to reuse this wastewater from the industrial, and I think it is better to talk about the history of desalination technology. Desalination technology is not new topic. According to the history of the desalination, Aristotle actually gives the first definition of the desalination. He says that salt water, when it turns into vapor, becomes sweet. And the vapor does not form salt water when it condenses again. This is now by experiment. Aristotle actually got this idea according to experimental methods. Later, in AD 200, Alexander of Aphrodisias, he actually gave one history about the desalination. He said some sailors at sea boiled seawater, and of course by suspending some actually sponge inside the boiling, or let's say inside the boiling or seawater, they actually take and absorb some drinkable water by using this method. I wanted to give this history. Later, I want to talk about the development in the desalination technology, especially at the mid of 1960. We can say there is a revolution in desalination technology. Near to 1960, we almost have 150,000 actual desalination facilities. But these days, this amount is increased at least to 86 million facilities. But again, we need to improve this desalination technology. Desalination process actually can be categorized according many point of view. One can be considered according the source of the energy. If the source of energy is thermal, we say this thermal desalination, or chemical, or actually nuclear, or also actually solar. But another method is using external or without using external devices. For example, actually, we can divide this in cat active or passive. In passive, which is known as the conventional solar steel. In passive desalination technology, there is no any more devices which should be connected to the desalination technology. These actually extra devices can be considered as a solar collector, as photovoltaic systems, or same as this also the waste, or let's say waste heat of the power plants. But on here I wanted to categorize this according this flow chart. Desalination process can be categorized in 4 main sections. Firstly, thermal method. Second, crystallization. Third one as a membrane, and last one as a ATA. Let's say new technology. During this presentation, I will focus on the thermal methods, which can be categorized in 6 main actually sections: solar steels, multi-stage flash, multiple effect desalination, vapor compression, membranes desalination, and of course the humidification. During this presentation, the solar steel and dehumidification methods, which are so actually inexpensive, will be considered. And here we can see the solar steels and its actually types. Again, we have many definitions for solar steels, and of course for the types of solar steels. And here I just brought 2 actually types as conventional solar steel, which depends on the design of the solar steel, and another as a cascade type solar steel, or even we can have something as a wicked solar steel. But during this presentation, conventional solar steel, or let's say the single slope, will be considered. Let's consider one conventional solar steel. Conventional solar steel, which is actually illustrated in this figure, consists of some actually parts. First part is basin liner. The second is the cover plate, and the third actually is the insulation section to actually prevent heat losses from the device, or let's say solar steel. One of the main disadvantages of the solar steel is their thermal performance. According to my survey, it's not greater than 26%. I mean, the conventional solar steel, 26%. 26% is not suitable thermal actually efficiency. During the last decades, research have been down. Many research actually have been done to increase the thermal performance or thermal efficiency, also to increase the daily productivity of the solar steel. I brought some of them on here, as utilizing suspended plate inside the basin water, or reducing the water depth, or using the external condenser, or actually utilizing the external and internal reflectors. According to these surveys, during the last months, actually, I consider my previous work, and I published one actually paper. I published an article related to the solar steel desalination. During my study, which is actually published in September of 2020. And during my actually study, I consider some actually parameters in the, their effects on the performance of the, solar steel. These parameters were the depth of basin water, depth of the suspended plate, and utilizing internal mirror in side walls. Let's consider our experimental setup. And here actually I fabricated almost 3 solar steels, but one of them during the experimental processes, one of them actually was broken. Then since of that, I just considered 2 of them. During the experiment, actually, some effects will consider as utilizing a perforated suspended plate with 210 holes and the diameter as 0.3 centimeters. Why we use perforated? Of course, inside the basin water. Of course, since I try to give this opportunity for the water to flow inside the basin water. The another modification in my case study was utilizing glass instead of something as a wooden, which is used in the conventional. Why I use glass actually as a material in my case study? In conventional, there is just one phase to capture solar radiation. To increase the amount of incoming solar radiation, I utilize this method. I actually designed this novel solar steel, as can be illustrated from the right side, which is the schematic view of the solar steel with mirror inside, and of course the perforated suspended plate at the bottom section. When sun, actually it should be mentioned that solar steel is oriented actually in east and west direction, and its glass cover, or let's say cover plate, is faced to the south direction. Now, when the sun, during my experiment, when the sun rises from the east side, solar radiation, or let's say sun rays pass through the east side, and of course from the top phase, and these sun rays captured by the basin water. The temperature of the basin water increased during actually this process, and the vapor which is actually supplied from the basin water is the vapor rises, and they contact with the glass cover. Since the temperature of the glass cover is cooler than the temperature of the basin water, the condensation will be achieved. Condensation means that you can take some potable water where the quality of this potable water is actually high, and it can be considered as a drinkable water. During this experiment, up to noon, the east side was open to the sun rays, but simultaneously the west side, covered with a mirror, and also the rear side during the experiment for the rear side we use one mirror again. When the sun rises from the east side and actually it passes through the east side, at the west side, sun rises reflected by using this mirror. Rays reflected to the basin water, and to prevent the energy loss from the left, or let's say not left side, it is better to say west side, we utilize one double glass. The gap distance of this double glass was selected as 5 centimeter. And by using this actual double gas and by utilizing this, gap distance, we can put some insulation material to prevent the energy loss from the west side. Of course, when actually we were in the noon time, the inverse procedure were actually processed. Of course, it was the experimental procedure. We actually did the numerical evaluation. For the numerical evaluation, of course, we have to consider the conservation of energy in 3 distinct sections, as basin water, glass cover, water inside the basin. I just put the conservation, some formula of the conservation energy without more details, but I should actually say that the aim of this numerical evaluation was calculating the temperature of the basin, the temperature of the glass, and of course the temperature of the water by using Fortran actually language. Later, the instantaneous daily productivity as daily productivity was calculated according to this formula, which equates to the amount of evaporated heat from the water to the glass over the latent heat. And of course, the instantaneous thermal efficiency at some interval times as 1 second was calculated according to this formula. Ag on here is this cross-section area of the glass cover, and I is the solar intensity. Now on here I brought actually some results, and I wanted to discuss about them. The variation of solar intensity by time of the day, and also the temperature of the basin water actually is illustrated on this picture. The highest temperature of the basin water was achieved when we use a mirror inside and perforated suspended plate inside the basin water, and the highest water temperature was achieved as I remember, it was 68 centigrade. Also the amount of solar intensity, there is actually 4 graphs. The red one belongs to the intensity. The amount of actually, let's say total. It is better to say total solar intensity also is increased, and the highest value was achieved as 1,149 watt per meter square. Let's consider the second figure of my results, and here we are actually seeing something about the mass productivity. The daily productivity versus the daytime is illustrated on here. But as I mentioned, we consider and we were looking for the effect of depth of basin water. Since of that, 3 depth of basin water were chosen as 2.6 centimeter, as 3.45 centimeter, and also 4.5 centimeter. During this actually experimental, also we changed the depth of suspended plate, and 3 actually depth of suspended plate as 0.7, 1.5, 2.2 were actually selected. According to the figure, the highest daily productivity was achieved at the case study where the depth of water was the lowest at 0.7 centimeter, and also the depth of basin water was lowest. As you remember, I said we have 3 depths of basin water: 2.6, 3.45, and 4.3. And according to the figure, it should be mentioned that the highest daily productivity belongs for the lowest depths of suspended plate and simultaneously lowest depths of basin water. And this is the figure which is talking about the thermal efficiency. Also, the highest thermal efficiency, same as the mass productivity, was achieved during the experiment when the depth of suspended plate was 0. Or let's say the lowest suspended plate, the lowest depth of suspended plate and lowest depth of the basin water. Also on here we consider the numerical method, and the result of numerical actually method is illustrated by the blue color. For the result of that study, I mean the first case of the study, I consider the cost analysis. One of the main objectives of designing solar steel is optimizing the cost. Now, we can see one table as a table 1, where the initial cost of the present, or let's say modified solar steel, and conventional solar steel actually are brought on here. As we can see, the lowest value belongs for the present, or let's say modified solar steel, and the price of designing and fabricating the initial cost, or let's say the initial price of design and fabricating the modified, or my case study, is $105, while the initial cost of the solar steel is $134.5. Then we can see that by modifying these, also actually we simultaneously, by modifying this, simultaneously we have some decreasing amount of the initial cost of the modified solar steel. During this cost analysis, I considered I tried to find the price of 1 liter for both actually solar steels. For modified, the cost of 1 liter for the modified actually was calculated as 36 cents, while the cost of 1 liter distilled from the conventional solar steel was greater than that, as 88 cents. Now I wanted to accomplish the case study, as a first case study, as a solar steel. Now I would like to consider the second case study, which is my future work. But before then actually considering my case study, my design, I wanted to give some idea about the humidification and dehumidification. As we know, nature uses air as actually carrier gas to desalinate seawater by means of rain cycle. In the rain cycle, when the seawater heated, we will have evaporating of the seawater. This evaporates actually will rise in some elevation. It will be converted to the clouds. Now, this procedure can be considered as the humidification. The next procedure, the humidification, can be considered when we have enough water condenses. The drops become heavy. At this time, rain falls down, and we can see them as river or lakes, or even they can actually flow inside the ocean, unfortunately. Now, it should be mentioned that the engineered version of the rain cycle is exactly humidification, dehumidification. Now, I want to show my second case study, which is my future study. I actually fabricated humidification, dehumidification, actually experimental setup, and as you can see from this figure, it consists of 3 main parts. But before then talking about the humidification, dehumidification, I think it is better to say something about the solar steels. The main reason for having the poor thermal efficiency of the solar steel is any functional processes as absorption of the solar radiation as actually evaporation, as condensation, or even heat recovery are occurring inside the solar system. And it leads to have lower thermal efficiency. Now, to overcome this problem, we can actually use humidification, dehumidification, where the humidification is actually occurred in separate actually device, or the dehumidification actually is conducted in another section, or even the heating of the water or the cooling of the air. During this experimental, actually the various temperature of the water, the various temperature of the inlet air, and also various air velocity were actually examined. As you can see from the humidification section, this actually device was made with glass, and I prepared eight holes on the upper plate in the cover plate, and to measure the temperature at some actually identified position. The main idea of this designing was to optimizing the length, or let's say the area of the humidification section. And also, this is the actually experimental section. After actually preparing some figures related to this section, I wanted to actually and of course, by using the experimental method and calculating the water evaporation, I wanted to compare this water evaporation by the empirical, or let's say semi-empirical methods. Then we can say the objective of this dehumidification is determining the water evaporation from the experimental results, which I actually discussed about that, create a new empirical correlation according the modified John Dalton's theory, which says us the rate of evaporation equals to A plus B, V, where A and B are constant value and V is the velocity of the inlet air. But it says that the water evaporation rate there is some actually proportional relation between the pressure difference at water surface and at the ambient, or let's say the air above it. And of course, I wanted to extract or establish one new empirical correlation, and then I wanted to actually verify this by my experimental results. I hope my presentation today will help you with what I said at the beginning about the water scarcity, and also the new technology, not new technology, the new technology from, the development of the new technology during the last decades. The references related to the actually my presentation are brought on here. Thanks for your joining and participation.